Let's get started.
It's not. Sweet. I'm just looking because I don't know exactly what today is.
Oh, not bad.
Come on.
Good afternoon, everybody. I know it's always a bit hard after lunch, but I'll try my best to keep you all awake with my demos on Program R, Raspberry Pi, Python, IoT, and live Power BI Stream Dashboard and Stream Analytics. And before we start, I also want to give a big thank you to all of our sponsors for sponsoring today, because without them this event wouldn't be possible. First, let me introduce myself. My name is Shreeya Subramani. I am a junior content advisor and trainer for Data Science Kids Academy UK. I'm also a junior data evangelist at Daydream UK. I've also spoken in SQL Relay, Microsoft Reading, and 3 other SQL Saturday events. And thank you, SQL Saturday Cambridge, for giving me this great opportunity to speak here. I've also attended and interacted with fellow speakers in MCT summits, SQL bits, and data awareness programs. I've also given interviews during this time. I've also completed and certified for 2 Microsoft training courses and 1 Harvard University training course, covering on Introduction to Data Science, R for Data Science, and R Basics respectively. There's no social media profile yet, but there will be one when I'm around 15, because right now I'm only 9.
Thank you, Shreeya. Hi everyone, I'm Dr. Subramani from Sivam, in short Manny. I'm a data platform MVP in MCT and MCC, and I've also spoken in various conferences and events, as you can see on the screen. Plus I also own 3 Power BI user groups and local groups. Those are some of my certifications, and you can follow me on social media. And maybe a bit delay, I may be not actively looking at my social media because I'm busy with clients and all sorts of things. So I will definitely get back in case if you have any questions. And this is one of the other events that I want to talk about. This is a kind of a childhood dream, like bringing data awareness program. So we are privileged to be here to learn more technologies. Like what about the non-technical people, like teachers, parents, students? So these kind of people, I'm trying to target the majority of the people. So for that, I started this dataip.org, and that's successfully running for the last 5-6 years now. And the second version of that is the empoweringeveryperson.com. So there's nothing to do with Satya's quote on empowering every person about Microsoft thing, but this is purely empowering every person with some decent level of awareness information. I won't take more than 30 seconds to explain what empowering every person is. And I've also done this, in various conferences and events. And I've presented this in Data and BA Summit Dublin, and at that time, this session has been awarded as the overall jury winner. That's because what we can do with Power BI is the overall extension that we are trying to show in there. And we have already sleeping data sets available in all government websites, and we have plenty of global challenges. It's not immediate threat to us right now, but it will be for our next generations. And so what we're trying to target here is, I'm trying to see all the global challenges that the humanity is facing at the moment. I'm trying to build some dashboards for awareness, and I'm doing that based on the data sets that are available in government and non-government websites. So this is what I'm talking about: plastics in a dead bird, air pollution, contaminated river, tsunami, global warming, and plenty of global challenges. And these are some of the reports that has been already published. You can just go to Empowering Every Person. And this is the Microsoft Power BI Data Stories Gallery, which you can try and browse by yourselves. So that's it from my side. And going back to the slide deck. So before I leave it to Shreeya, I just wanted to show, she broke her leg 2.5-3 months ago. And she was in her wheelchair for the last 2.5 months. She just literally started walking for the last couple of weeks, and she's in her crutches at the moment. She also broke her thumb, which she didn't know for the first 3-4 days. And then she survived with all of these time. And last 1 week, she was really very cooperative and helpful for knowing and doing all of these sort of demos. Off you go, Shreeya.
Thank you, assistant. Okay, so now let's talk about the contents that I'm going to cover. We've already done the intro, which was for 5 minutes. Then I'm going to talk about DSK for 10 minutes, my involvement in DSK for 5 minutes, demo on DSK for 5 minutes, about Raspberry Pi for 5 minutes, demo on Program R for 10 minutes, IoT summary of hardware, software, and setup for 5 minutes again, and then the rest of 15 minutes would be a demo on Raspberry Pi, IoT Hub, Stream Analytics, Power BI, and for 15 minutes. Now let's talk about DSKA. DSKA stands for Data Science Kids Academy. We run DSKA in London for age groups 9 to 18. And in the past, we have run short-term courses, and now we are launching annual courses covering on data science, machine learning, artificial intelligence, and IoT globally. And if you are interested in starting a franchise, please contact my assistant, and his email address is manny@djm.com. Now, once you enter our website, you'll find that we cover coding, workshop, courses, and training. Now, I'll talk to you about what will happen in DSKA. As you can see, we have 4 terms for each age group. And at the beginning of age group 2 and 3, they will have an assessment exam. And at the end of each term, we will also have a term exam. And each term consists of 12 to 14 weeks, 3 months, and then overall 1 year. We've also got 3 levels: basic, intermediate, and advanced. And on the top right, you can see how many hours during the year for the levels. So in the first age group, there would be 45 minutes per session a week, and then that would be 39 hours over the year. Same for the second and third age group, but 52 hours and 65 hours. Now, the contents level, we have a table again showing the levels and the age groups. So each triangle represents the complexity of each level. So the bigger the triangle, the harder, the smaller, the easier in each age group. Now, let's talk about what we deliver and the delivery methods and what topics we cover. We cover Python, R, data science, machine learning, Power BI, AI, SQL, and IoT. We also give out homeworks in quiz forms, report build, Excel and Power BI, watch video courses, term and final exams. Now let's talk about my involvement in DSKA. Well, for starters, I'm a junior content advisor helping in course contents, advice on animation and image and graphics, learning from existing to compare with market and testing user experience. So on the right you can see some animated videos which I've been recently helping to make so that we can use it for DSKA. Now I'll show you a demo on DSKA. Okay, so once you enter the website, again, just like I said at the beginning, we cover these subjects, and if you've done edX courses, you might find it a bit boring, but in my opinion, I think that DSKA has a more fun way of learning. So if we come into the history of R, for example, it has a little graph over here, as you can see. It also has information which is splat out easily to read and understand. So it gives you all the information. And also it has basics like in R objects, so if you press you can read it. So this is a vector, and then you can take it off again. So it's more interactive than edX courses or Microsoft or something like that. Matrix, list, and a data frame. We also have some interactive videos over here, and we have also got some practice questions to boost you up. So it would give us something like this. So instead of going to R and then going onto it, and if you don't have it already, then installing it and blah blah blah, you don't have to do that because we've already got R in our workspace. So you can just do run, and then you can see all the values: numeric, 1, character, logical, and complex. We also have homework. So for example, homework on statistics. You would find the mean of the following numbers. I'm just typing in a random number. Might not be wrong, I don't really care right now. But yeah, so it gives you examples to boost your brain about what type of questions there would be. I don't really, yeah. So, 2 more questions. And then we also have easy pictures to help as well. So it would So in DSK, we would split it up, and then we would also give you pictures to help you understand better and further in. We also have a few interactive videos with people actually doing it, with some of my assistants' colleagues doing it. And we've also got photos from online and some things, and we've also got much more information. And we've also got many homeworks, about 5 homework courses. So it's interactive because you can drag and drop everywhere. But you get the idea, don't you? And it's also got another few sets of practice questions. So if I just type in a random number, I don't really care again. So yeah, you can understand that it's giving you more like high-level questions and to make sure that you understand it. And we also have our last one. So it gives you slides, and once you complete each of the courses in it, then it will put a tick mark, and then you can see how much % you've covered and everything. And we've also got more interactive videos. So now let's get back onto the Now let's talk about Raspberry Pi. Here's a simple table that shows Raspberry Pi sold in the past few years. So you can see that it was released on February 2012, and by March 2018 they sold 19 million. The University of Cambridge and Broadcom made Raspberry Pi's first version in February 2012, like I just said. They aim to promote study of computer science, especially at school level. As of now, there are Model 0 AB with dozens of generations. Now I'll show you a demo on Excel and Program R. So if we wanted to predict how many Raspberry Pis would be sold in 2019 and 2020, based on the information we've got already, what would we do in Excel? Well, there are 2 methods. You could use a regression model, or you could use a scatter chart model. So let's do our scatter chart model first. So if we name this column X and this column Y and a new column called new Y, then we would select our information here and we would insert a scatter chart. So here is our scatter chart, and we would right click on one of the dots and press add trend line. And then we're going to press display equation on chart. But now we want to make sure that our new Y value comes more close to the values that we already got. So we're going to press on our equation and go to this bar graph type symbol. And in general, we'll press number, and here in decimal places we want 5. Okay, so you can see that our equation has changed. So now let's write in our formula. Equals 0.04456 times X value minus 8974.12303. When we hit enter, you can see that we get 4.8 million as our answer, as new value. So, if you wanted to do the exact same for all of the other boxes over here, it would take a really long time, right? But I've got the secret method. Go until you get a black arrow under when your mouse is on this little green box. Double click, you get it without doing anything. Now, here's the real magic. If we type in 2019 December and hit enter, it just comes automatically. And 2020 December automatically again. So, we can predict that by next year, December, there will be around 23 million Raspberry Pis sold, and by 2020 December, we would have 28 million sold. Now let's see regression. We would go on to data analysis, and we would go down until we see regression and hit OK. Now we're going to input our Y values, our Y range. So we're going to drag and drop, and same for our X range. And then we want our output range, and now I'm going to select a box which I would want it to end up in, and I want it residuals and standard residuals. Hit OK. We've got a pretty big formula thing. So now we're going to come back over here and equals. Can you see this number? We're going to type that in. 0.044562 times x again, and then minus this number. Minus 8974.12. When we hit enter, you can see that it's not exactly the same as we got for our first one, but that's okay because they both are near to 5 million, because they don't exactly have to be the same. Now let's use our magic trick again. Double click, and we get it now. Now let's type in 2019 like we did for the last one. December 2020, December. Now I'm going to show you what would happen in program R. Here you can see that we have got some writing and blah blah blah. So now we want to store these two variables into our console. So what will we do? Well, basically we would select and then we would hit run. And now it's stored. But to make sure that it is stored, we're going to double click on our variable and hit run. And then as you can see, it is showing us the value stored in our variable. The same can be done for in millions as well. Now let's combine our columns to form a meaningful data frame. So for this, as you can see, my assistant has written some code, but it would be a bit of time waste if you select this and go run and then go back. So instead, we have got the same variable again. So what you can do is select all of it and hit run. And when you hit run, you can see that it has stored it and then immediately it has given us our data frame. Why? Because we've got our variable right underneath and we selected it. And we could do the same for our variable LM as well. So you can see that it's done the exact same. Now let's use the predict function based on the above coefficients and project predicted values. So we'd select this and we would hit run. So now you can see that we've got our new values. So if we want to, compare these answers with these first 5 answers, you would see that they're not the same. But like last time, that's okay because they all are rounded, and when they're rounded, they're really close to these numbers over here. Now for a user-friendly column comparison. So we're going to select it and hit run, and let's see what happens. So you can see that it has given us a data frame of the year, month, in millions, and our new value, which looks almost the same to this, but with different values for our new y. So now let's pass the new data to predict and make a data frame. And did you know that instead of selecting one at a time for different ones, you can select all of it at the same time and hit run? Because if I want to do, I could just select all of it and just hit run and then go on to the next slide if I want to do that. Now we're going to see what happened. So it stored both of these first, and then we're getting our data frame for the year, month, new. So you can see that we are now probably going to go and find out our values for 2019 and 2020. So we are going to select this to predict it, and now we've got our values. So let's compare them with these two values over here. Well, if you round them to the nearest million, you would see that the first one rounds to 23 million and the second one, they both round to 28 million, which means that they're close. So now let's do it again for more fun and learning. And it's given us another data frame over here. So just to make it easier to understand of the year, month, 2019 and 2020, and how many might be sold. Now let's plot a scatter chart to show it. So if I hit run, you can see over here that we've got a scatter chart from 2015 all the way to 2018. And the little dots are the scatters for the scatter chart, basically. And now let's get an absolute line. So we'd hit run, and here you can see that we've got an absolute line. So it's going up. It's just like the trend line that we saw in our earlier in Excel, right? So what would you do if you don't know what one of the functions mean, but then you want to find it out in Program R? Well, you would put a question mark and write the thing. So if you don't know what plot is, then you write question mark, plot. And then if you run it in our console, you can see that it gives us a information about plot. And that's quite a lot, maybe. Anyways, now let's select this to merge the total results. So select it and run. So now it's given us another data frame, but this time from year month to 2020 and in millions all the way to 2020's value. Now let's make another scatter chart, but this time including 2019 and 2020. So we're going to hit run, and as you can see, we've got another scatter chart here. Do you realize anything different? Well, you should, because there are 2 more dots added for 2019 and 2020. Now we want an absolute line again, so we're going to hit this and hit run. Over here, so we've got an absolute line going from 2015 to 2020. Okay, so now let's go back to our slides. Okay, so let's talk about our summary. Okay, so we recently added IoT as one of the key stuff to our DSKA course. I would also like to show you what I have done to set this up and give a live demo on reading this temperature using the sensor over here. So this is what the sensor is. The sensor and live stream of the data to Power BI. So I'm going to take you through all required hardware, software setup as well. Okay, now let's talk about the hardware. We are going to need Raspberry Pi, 16 GB micro SD card, which is the minimum, but for this demo we are using 32 GB, SD card reader, 18B20 one-wired digital temperature sensor, Wi-Fi dongle, breadboard, 3 female-to-male jumper wires, 2 male-to-male jumper wires, and 1 4.7K ohm resistor. Now let's talk about the software flow. So first, we are going to format the SD card using the SD card formatter, which we then are going to open Windows 32 Disk Imager and feed Raspberry and OS into that. Then we're going to open Advanced IP Scanner and scan to see if there's any available systems to connect to. And then we're going to type in that host name into PuTTY, and then PuTTY will open up a console for us to write in. So this is what the fully assembled hardware looks like. So you can see over here, if I show you quickly. So this is our Raspberry Pi, this is our power supply, Wi-Fi dongle, 32 GB micro SD card. We've also got our 3 female-to-male jumper wires, our 2 male-to-male jumper wires, our 18B20 one-wire digital temperature sensor, and I know you can't see it, but between these cables and these cables, there's our 4.7K ohm resistor. Now I'll talk to you about the demo flow. We've got our fully assembled hardware over here, and then we're going to dip the sensor into hot and cold water. Then we're going to open Python scripts using the device ID of our temperature sensor, and the other 4 is from IoT Hub. Then we're going to send that to Stream Analytics job, and then we'll send that to custom streaming data Power BI. And this is what our live data chart might look like, but it will have different temperatures to this room temperature. Now I'm going to show you the demo on Raspberry Pi. Okay, so first, let's get Windows R and type in CMD, short for command prompt. When we hit enter, we get a console. And I'm going to type in IP config
We
to
don't-
find the current.
We don't see it yet.
Oh, sorry. Okay, let's start from the beginning. Sorry. CMD is short for command prompt. And then we're going to type in IP config to find the current IP address and range. When we hit enter, we get all of these values. And we're going to take the default gateway, and we're going to open advanced IP scanner. And we're going to type that number in, but it's already typed in. So then, if it isn't typed in, you would type in the default gateway number here, and then you'd write 2254. And then you would press scan to see if there's any available systems. So at the bottom here, you can see how many are alive, how many are dead, and how many are unknown. So it's just starting. So it'll take a minute or two. So we've got 93 unknown, 1 alive. Okay, so now we are going to take this one, Belkin International, INC. Alright, now we're going to see if we can ping this. So we're going to right click, go into tools and press ping. Then we get another console, and then you can see that it keeps going and going and going and going. So that means we're good because Raspberry Pi is responding. So then we are going to open PuTTY, and we're going to type in this number in there. So 192.168.43.15. Press enter. Now give me a second, I'll quickly log in. Okay, so you can see that it says Pi at Raspberry Pi. That means we're right now interacting with Raspberry Pi. So I'll just type in my pseudocode, sudo mod pro w1 dash gpio, sudo mod pro w1 dash therm, which stands for thermometer. And then we want to access another file. So we're going to type in cd, which means change directory. And then we want to access the file sys bus w1 devices. When we press enter, you can see that sys come in blue, which means that we've entered the folder. So I'm going to type in ls now to see what's in it, and I want to come into this folder. So I'm going to type cd, and instead of copying and pasting, I can just select and then right click and it'll come up. Okay, so now to make sure that we are working correctly, I'm going to type in cat w1 underscore slave. And when we press enter, it says no. No.
Keep going.
This is fine. Okay, let's just go back to our original value. Okay, so let's enter cd scripts, which is scripts is one of our files. And now we entered scripts, so we're going to type in ls to see what's in that folder. Now let's use Python by typing in Python, and now let's use our inconsole.py.
So basically in console.py is holding Python scripts, which is actually reading the data from the sensor. So this is the one first what you said, the 28-03 is the device ID of this sensor, and it is trying to ping to see the room current temperature. So the current temperature is 25, and this is only to identify the temperature in this console. We haven't started feeding this data to Azure IoT and to Stream Analytics. We haven't started that process. So we have something separate Python on that one. So we go stop this and then go to the second one.
Okay. So we're going to type in Python at this time Azure IoT.py. Enter. And as you can see, it's detecting the temperature again, but you can see that it's in a different form, saying temp and then temperature.
So that's the way it is being formatted. So this is the script. Basically, Python has got it. And as you can see here, that's the device ID what we have programmed. Plus, it also uses 4 other information. So these 4 are coming from the IoT hub. And I will show you where these has actually been extracted in portal.azure.com, and also where we are using the portal's output to our Power BI report. Right. So I'm going to exit from this program, and we need to keep running this Azure IoT PY so that we can start pumping the data to the cloud. So I'm going to quickly log into the portal. So what I have configured here is I have a separate resource group for this specific demo, and all I have is 2 stuff that I've configured, the IoT and the SA temp job. So I don't want to waste time, so I want to kickstart the temp job, which is being stopped earlier. It was consuming my funds, what I have in my account. So I just want to start doing the demo. It takes a couple of minutes. By the time I can finish showing you the other stuff that I have. So this DSK IoT is the IoT that is configured on that. The host name, what you see here, is the host that you are actually seeing in the console. I've also strapped something with the cello tape just to make sure that the connection doesn't go out. Unfortunately, the sensor does not have the same pins like the male and female jumper pins, because they do have the cables just connected. So 85 degrees, wow, we're burning. Okay, so while that's trying to execute, and as you can see, that's been running on the other side. And this is the host name that I'm using it there. Plus, I also go to my shared access policies. In here, I use this as a policy. And when I go into that, I get this primary key. So I feed this key for my Python scripts. Then I also have to use an IoT device ID, which I created here as RASP DSKA. So these are the 4 information that you have seen in my Python script. It never showed me any errors. I've done at least 5 full demos since this morning. So let's go back to the Stream Analytics job. So that has started. And what I am actually configuring in the Stream Analytics jobs is I have an input, and as you can see, this is a DSK input that I give by gathering the data, and I also have an output here, which is the DSK output. This has got a dataset name, which is fed as dset DSKA, and this is the place where I'm authorizing my Power BI account, that one, to show the actual demo. So as you can see here, that's a demo of the actual Power BI live streaming the data. So this was from my previous session. So I'm wondering whether it is still pumping the data or not. It's not doing anything. So basically you have seen the data that's running through here, right? So this is the same thing that it will respond to show all of the temperatures that's coming up. This one is 2:13. So as you can see, that's a different time. That's the last time I ran. And it refreshes for every 15 seconds on this particular tile. And if I go away from this screen, I'm going to lose this, and you can't see the data is being streaming at all. So I'm going to try opening a new session. And also, as you can see on this one, I have a query which is simply reading data, and I'm trying to convert the data into a simple temp date and the temperature, and I'm putting that into DSK output. And the DSK output is connected to my Azure App Power BI website, and I can see the output on that one. So if I go to my workspace, I can see that data set is being automatically created. I didn't create this one. And if I go to my dashboard, and if I create a new one, and I can say add tile, I'm going to choose custom streaming data and hit on next. I have options to choose what are the options that I have. I'm going to choose that one, and I'm just going to choose a line chart, add a value as temp date, and that one as temp. As you can see, the data is not flowing through right now, and hence we're not seeing anything in here. and it has detected now the time is 3:30, and we lost all the data that we had earlier. Let me try going back here and exit. Go back to my scanner. I'm going to give a quick scan. While that's trying to scan, I'm also trying to log into the device. This time I'm trying to connect with 26 because by default, Raspberry Pi latest model, I've got inbuilt Wi-Fi, which you can connect. You don't need an external dongle to connect to get internet access. As you can see here, Raspberry Pi is its own default internet Wi-Fi, and that's the bulking one which I actually additionally added because it was a bit flaky initially, so I want to make sure that I have a dedicated connection. So earlier, Shreeya was doing a demo against 15, so I'm going to try and do against 26. And before that, I'm just going to make sure I can speak to that. Okay, so that's going good. Let me choose 26. So this mod probe is actually going to initiate the libraries and the functions that is to do with this specific demo. So that's only two quick things. And we can go to the CD scripts. So when you go to list, so this is what we got. I'm going to execute the script here.
Script?
Yeah.
So where is it located? On your computer?
On the storage. We have the storage card on that one, right? So we store everything in the storage. So anything in this console, what we are trying to interact is to the storage device on that one. These are the Linux commands we're trying to execute that, and we store some Python scripts on it. So we just got some hot water and cold water, but we can't do it because it's not running the scripts.
Like when that 85-degree temperature, where you move
Yeah, it's a glitch actually. It's a glitch. Initially it came just like 85 and then it came out. Ah, there it is, 78.437. Is it really that hot? Keep checking on that one. No, that was not hot. 79.
It's hot.
It's really hot. Yeah. So there seems to be communication gap or kind of internet connection things is what makes us gives us a problem in here. So that's the cold water. Let's see if at all it really detects any cold one. Probably. Python scripts are a bit flaky in that location. So usually, like when we try and do that, even if there is any space which is not relevant to, it's not visible even to naked eyes. We can't see anything. Even if you select it, you don't see anything in the background. But
It's working.
There you go.
It's working.
Let's see.
It's alive.
There you go.
Awesome.
So that's the hot water thing. That's really 86 actually. But without dipping the water, we had 87 earlier.
Yeah.
So let's put in the cold water. Is it cold? Yeah, a bit cold.
It's not very hot.
Yeah, it's a few seconds lag, right? Stop. Anyway, you see the picture, like how it actually you can feed the live data on these ones. We're also working on various other stuffs, but we just want to show this is going to be very simple. We just added this as our additional module for our Data Science Kids Academy stuff. And okay, so we have a working demo at last. Sorry about that, but it's stopped now anyway. Okay, so it's totally stopped. Off you go, Shreeya.
Now, I know what you guys are wondering. What am I trying to achieve with all this? Well, data science, machine learning, artificial intelligence, and IoT are the main components for robotics. I'm helping my father to build blueprints to build some useful robots to help disable human beings. And I love all of these methods and techniques for doing these as well. Any questions?
You mentioned the courses online earlier. You have terms. Are they kind of set dates, or can somebody start this course?
So that's about to launch now. So which means like it will be started by term times actually. So every 3 months kind of thing. So we are trying to line up with the actual school terms.
Right.
Any more?
Which of the things you showed us is your favorite to work with?
Maybe the Raspberry Pi. But any more? Okay. If I made you to sleep, please stretch your arms and legs, and thank you for listening to my speech, but I'm not done. We've also got the sponsor raffle. Collect 7 or more sponsor stamps on your badge to be eligible for the Xbox One X. OMGs. I'd want to get that. And we've also got the social thing. Giant Jenga, giant Connect 4, Drag Plum is SAT process. And yeah, now really done. Thank you.
Yeah.
Thank you,
Well
everyone.
done. That was good. Thank you.
It's amazing.
Yeah.
So I did my
Thank you. Thank you very much. I learned
Thank
a
you.
lot.
Okay, sorry. You're not doing any major.
Times like particular bit late,